Good afternoon. Welcome back to the chemical equilibrium. Yesterday we have seen the why we should what is the essence or why we should read actually the chemical equilibrium. Chemical equilibrium requirements is wherever you want any chemicals production, HCl production, water production, ammonium production, or any such type, all medical fields and all these things. You should know about the Kc. Then only you will come to know at what temperature and all these things. So, what is the first one? Predict. What is the use of this one? Predict the extent of reaction. Extent of reaction on the basis of magnitude. Magnitude. Second one is direction of the reaction. Whether forward reaction or backward reaction, which is the predominant. And finding out equilibrium concentrations. So we'll see. Now suppose Kc, that is equal to constant, is more than 10 to the power of 3. It is predominant, forward reaction. Forward reaction. That means it will proceed to the products. If Kc is less than 10 power 3 minus 3, less than the 10 power minus 3, that is, it is reactants. If Kc equivalent to the this one 10 to the power of 3, then it will pay equilibrium and all these things. Some small examples we will see, then we will come to know the what is the values and then how it will be this thing. Everybody knows that hydrogen, 2 hydrogen reacts with oxygen at 500 in equilibrium at 500 degree Kelvin. Then you will get the water to the ballast equation, right? It's the Kc equal to roughly 2 into 10 power 47. See, very big value. So that means this reaction at this temperature, equilibrium temperature, it will move towards this one. Reverse you take. Reverse is water is dissociating into hydrogen and decomposition into oxygen. The reverse one is Kc equal to 10 power almost equal to 10 power minus 48. That means water dissociation is very difficult, whereas at 500 degree Kelvin, hydrogen and oxygen, if they are meeting, you will get a water. So that is the, from the magnitude of the Kc, that's what they predict the extent of the reaction on the basis of the magnitude. That will be this one. One more example we'll take. This is the first example. Second example, hydrogen plus chlorine gas gives hydrogen chloride. That will be this thing, all are gases only. Fine. This Kc equal to roughly 4 into 10 power 31. That means forward reaction is very predominant. So this is feasible. Why? By seeing this, whether I have to establish a factory or chemical industry or something, then the economicality means viability, so many things we will come to know by seeing this first, this value. This is the start. Similarly, hydrogen plus bromine gas gives hydrogen bromide. Kc equal to somewhere 5 into 10 power 18. That means it is also favorable. Then suppose this fourth reaction. This reaction already we have seen, the reverse reaction, not favorable. This thing, nitrogen and oxygen gives nitric oxide. 10 to the power of minus 31 is the value. That means not favorable reaction. So that is this thing. If it is more than 10 to the power 3, then Kc. If less than Kc is less than 10 to the power minus 3, reaction fine. Direction anyway you are able to see which direction the value is more, then that will be the another value also. This thing, reaction coefficient also, that is also same. Reaction coefficient is nothing but, suppose if you see the general reaction, AA plus BB is in equilibrium with CC plus DD. For this reaction, what is the QC? QC and KC is one and the same almost. C to the power C, D to the power D, by A to the power A, B to the power B. This is this thing. Then for general reaction. But what is this thing? This is QC is not equal to KC. It can be equal, but at any point of time also I am finding out the QC value. Otherwise, what is the fun in writing again the same equation? Kc is equal to same reaction at equilibrium. Now I am writing a general equation at any point of time. That is remembering what is the difference between the QC and Kc. See, immediately after the reaction starts, or the sometime concentrations. Suppose now, if QC is less than Kc, reaction will process further. Reaction will proceed towards products. If QC is greater than Kc, that is reverse reaction to the above, means reactant side, reverse reaction, that is the reactants. If QC equal to Kc, it is already established, that means it is in equilibrium. Just for this thing to understand more clearly, one more example. Same hydrogen and iodine, bromine, like this. Hydrogen reacting with iodine gives 2Hi in equilibrium. Okay, that will be Kc is 57 already available at 700 Kelvin. Okay, now I am taking a concentration of the hydrogen gas, concentration 0.1 molar. Iodine is we are taking as a 0.2 molar, and the Hi concentration I am taking some values I am taking. At this concentration we are taking out the concentrations and measuring the equilibrium constant theoretical value. What will be the theoretical QC? QC equal to same 0.4 into 0.4 because of 2Hi, Hi square, by 0.1 into 0.2. So 0.2 is 2 times, this is nothing but 4 times, nothing but 8. That means QC is 8. Whereas actually Kc equal to already given as 57. That means it is not reached the equilibrium. QC is less than Kc, the first condition. That means reaction will proceed further towards the, till Kc is 57, it will proceed. So QC is nothing but a coefficient, reaction coefficient at any time, whereas the Kc is at equilibrium. Remember the values. So which direction it is? By otherwise in the practically, how do you know whether we are reached the equilibrium or not, whether it is proceeding further or it is going to proceed in the negative direction? All these things will be by QC measurement and concentrations and all. Right. Now that will be the, if QC equal to Kc, there is no net reaction further, this thing. Then how to calculate the equilibrium concentrations we have seen yesterday, whatever it is. Then what will be the reaction between, means what is the equation between the relationship between the free energy that we have seen already delta G, that is the spontaneous reaction, and the what you call equilibrium constant, that we will see tomorrow.